Welcome to section 2.7, cylindrical and spherical coordinates. This is checkpoint 2.55. We have a point that's written in cylindrical coordinates expressed as 5, pi over 6, 4. And they want us to plot this point and describe its location using in space using rectangular or Cartesian coordinates. Rectangular and Cartesian coordinates are the same thing. So let us see if we can get this. Well, let's first identify the points that we have. We have r, 5, pi over 6, 4. And let's identify that the first number is r. The second number is theta. And then the third number is z. Okay, so let's see if we can draw that in space. Let's draw our usual x and y and z space. Except now, if we're going to talk about cylindrical coordinates, instead of having our coordinate systems going like a rectangle or squares in Cartesian coordinates, we could imagine that our system would be made out of circles on the xy plane. That's one set of coordinates, and the other set of coordinates would be these things that we'll call rays. And we've seen like the two-dimensional version of this, and in fact the two-dimensional version of this is exactly polar coordinates. So if we were to look at it at an angle, if we're looking at it straight on, everything would look like circles. But we're looking at it at a little bit of an angle, so it's slightly skewed a little bit. In any case, we're going to identify this point. If we just focus on these two values, we can look at that on the xy plane as a radial distance of r, of 5, and then up an angle of pi over 6. So this is your angle of pi over 6, and it'll be some point that would be made from that angle. So here we have 1, 2, 3, 4, 5 along the axis, and then we would go a short way angle of pi over 6, and this is going to be the equivalent point 5, pi over 6. And right now it's sitting at 0 because it's still on the xy plane, so your z component there is still going to be 0. But we're going to want to take that up 4 units, so imagine going up 4 units, 1, 2, 3, 4, and we'll take that same measurement from here and go up 1, 2, 3, 4, and there you would have your point. So what did we do? We went an r distance along the x, we went an angle of theta, and then we're going to go up 4 units. Okay, so this point now, this is the point that we're looking for. This is the point 5, pi over 6, 4. So that is, if we want to say it in words, it's going to be 4 units above because it went up 4 units in the z-axis. It's 4 units above the xy plane, and right above the point, above the polar coordinate point, and the polar coordinate point of 5, pi over 6. Okay, so that's the way to describe it, and this is the way to try to view it in 3 dimensions. Okay, I hope that helps.